success here. All right. So what we're going to do today is we're going to look at some answers, and you're going to tell me multiple choice. You're going to tell me what is the same and what is different. Okay. And it could just be a single word. So I'll do this one as an example for you. For the first one is R increases at a constant rate, V increases more rapidly if interest is compounded annually rather than daily. Letter B, as R increases at a constant rate, V increases more rapidly if interest is compounded daily rather than annually. What is the only difference or small differences between A and B? What are the only? What is the main difference that you see?
Um, hmm. The D doesn't have like an increase.
We're looking at just A and B. What are the main differences between A and B? Forget about C and D, just A and B. There's one keyword difference in them.
Daily and annually.
Yeah, annually and daily. Okay. Now C and D are kind of very different. C starts out the same, but then it talks about something else. So not always, but usually the two answers that are mostly the same but have flips of words, they're ones that they're ones that you can see go up. These tend to be the answers because they're the flips of one another. All right. So now let's look at the graph here. I'm going to just put up a graph here. And it's kind of the same, it's kind of the same question. It's like, what do you see that's the same or different? Like, what do you notice about what you're looking at? It's really an important strategy to be able to differentiate here. So here's a graph. Take a minute here and tell me what you see that's the same or different. Like what do you notice when you look at this graph here?
Um, and just daily and annually.
Okay. Now let's look at the actual graph. Which one do you want?
Uh,
If you like money, if you like money, if you think money's important.
I don't know, annually,
Which one gives you more money at the end?
daily.
Okay. So daily is better if you like more money. Why would having more money be important?
Isn't that what we're looking for?
Yes. So sometimes it goes back to it's that simple. Like I don't even need to put the question in front of you. You like it doesn't matter what the question is. Which is better, annual or daily?
Daily.
There's your answer. I'm going to put the whole question up in front of you. And this could be a little overwhelming. But if you use the strategy that we just talked about, all right, which of the following true? You read the answers, you recognize that these two are probably the answer. Then you go look at the graph and you realize that it's B. It's pretty doable. And yes, this strategy worked this way for almost every problem that we're going to use. Like for every problem we use it for, you really can like almost figure out the answer without reading the question or the rest of it. Okay. So here is another multiple choice answer. Okay. Look at B and C first. What is the same? What's different?
Greater and less than.
Yeah. Okay. So we could, if it's a chart or table, we can quickly figure out that. How about the bus had the most riders on Tuesday? What does that mean to you?
Uh, I don't know.
Well, what do the words mean? Come on, like, what does that mean?
That there were the most riders on the bus Tuesday.
That's right. Exactly what it says. What about down here?
The the fewest.
Yes. So see how there's also kind of a comparison there, greater, less, most, fewest. So while B and C are written the same, A and D are kind of like also related. Okay, so now let's look at the table. Which day had the most number of riders?
Um, Friday.
Yes, Friday. So is that the most riders on Tuesday? Is that
No.
one true? No. All right, let's look at D. The 2 days of the fewest number of riders were Saturday and Sunday. When were the fewest number of riders?
Uh, Sunday. Sunday.
Saturday and Sunday. Is that answer D?
Yeah.
All right. Good job. This is letter D. So it doesn't just work for story problems, although it tends to be mostly story problems that you see this with. We're going to look at another problem here where I'm just going to snip in the answers. All right, tell me what you see. What's the same kind of it's that overarching question. What's the same or what's different?
Uh, C and D, it's like infinite solutions, and D is none. I don't really know about A and B though. I mean,
So you could say that these are numerical, like these are actual answers,
yeah.
actual numbers, whereas these are more like descriptions. Good. Okay, now let me put something in front of you. 2x plus 3 equals 2x plus 3. Does this have one solution, no solutions, or infinite solutions?
Uh, no solution or infinite or
Which one?
uh no solution.
Okay, so here's how we solve this equation. We're going to subtract 2x from both sides. And this is 3 equals 3. Is this a true statement?
Yeah.
Yes. So when you get the same number on the left and the right, even if it's 0 equals 0, this is infinite solutions. So what you're looking for is same on the left, same on the right, infinite solutions. Now let's look at a different problem. Let's say it's 4x plus 7 equals 4x minus 3. To solve this, you would subtract 4x from both sides. Is this true?
No.
This is false. This is no solution. So whenever you get a number equals a different number, that's no solution. Last thing here is what if you solve something like this, 5x minus 1 equals 4x plus 2. if you subtract 4x from both sides, add 1 to both sides, you get x equals 3. Is this a solution?
Yeah.
This is a numerical solution. So there's 3 possibilities, okay? Now let's go look at the equation. Let's look at a new equation. All right, and what I want you to do here, this is going to require a little bit of effort here, is I want you to distribute the 7 to both of these terms on the right, please.
Uh, no solution.
How do you know that?
So at the end, I got -14 equals -98. That's not true.
Okay, so you solved this all the way through.
Yeah.
Okay. But so just to be clear, like I asked you to just distribute in because you don't even have to solve this.
No.
You don't have to go any further than this. You just have to see that this is 7/2 x, and are these the same? Well, these are the same, but these are not.
Uh-huh.
And that's far enough. Like you don't have to do anything more than that. Once you decide that they are not the same, but that the variables cancel, you know it's no solution.
Okay.
All right, so let me see if I can find a couple more problems like this. All right, so here is here is another problem for you to look at. What I'm asking you to do though is not determine the solution, just determine if it has one solution, no solution, or infinite solutions, and try not to actually solve it.
Um, think you have one solution.
Okay, so when I distribute here, I get 10 minus 3x minus 6 equals 3x plus 4. You're really looking at the x variables. Are these the same?
No.
They're not, which means you're going to get a number. You're going to get one solution when you do this. Good. All right, so here is another one for you to look at. Same idea. It's kind of like how many. Tell me whether it has one solution, no solution, or infinite solution.
Uh, all or infinite solutions.
Okay. Infinite solutions here. So that means it's exactly the same on the left and the right. X plus 2x minus 8. 3x minus 8 equals 3x minus 8. So notice they're exactly the same. So yeah, it's infinite solutions. Good. Very good. Okay. All right. I like it. Okay, let's look at another problem here. Um, may have actually looked at this one last week. I can't remember. All right, so what is the same? What is different about this?
Uh, I mean, it's just plus or minus.
So let's use some different words here. These are all equations of lines. What does the equation of a line in this case, what does the 2 represent in this equation of the line?
Uh, the y-axis.
Nope, that's the other number. Lines have a slope.
Oh, the 2x.
What
The
is
x,
the slope or the b value? These are all in the form mx plus b.
2 -3.
Okay, so this is another way to look at it. What about the second equation? What's the slope and the b value?
2 3.
Okay, so what do they have that's the same? What do they have that's different?
Uh, the b value
The b value is the same or the b value is different?
different.
Okay, slope is the same. Let's keep going here. Slope is 3, b value is -2. Slope is 3, b value is 2. So it looks like 2 of the equations have the same slope, 2 of the equations have the same b value. So you can either use the slope or the b value to answer the question.
Okay.
All right. So that's what I'm looking for. And it just, I mean, it would really help me, Tristan. You just give me a tiny bit more energy um, today. I just don't feel like there's much desire, and I get it. It's Sunday, it's early, but we are we we do this every week. So just give me a little bit more effort, please. Really appreciate it. Look at this graph here. What is the slope? What is the b value?
Um, would it be 2? Wait,
Which is 2.
the um the slope.
Okay, slope is 2 up, 1 over. Is that what you're thinking?
Yeah, but I
Is
mean
it,
it's not quite 1.
so this the slope is not 2. It's gotta hit a perfect, grid spots where they come together.
Mm. Then 3 3
Yes, 3 over 1. What is the b value?
uh 1.
So you're saying it crosses the y-axis at 1.
Oh, no, -2.
There you go. Okay, so now when you go back to the answers, which is it? Which of these matches up with a slope of 3 and a b value of -2?
C.
Okay, good. All right, so are you starting to get the sense of what we're trying to do here by looking at the answers first?
Yeah.
Okay. So I'm gonna have you try some on your own. You do not have to use the strategy, right? None of the strategies are 100%. always going to work, but I strongly recommend it because they're all which of the following. So I would recommend reading the which of the following, reading the answers, then deciding what other information you need. Do not guess. If you're not sure, just say, I'm not sure. But take a full minute here and see what you come up with.
Okay. Is it B?
Okay, how do you know that A is greater than B? It is B, but how do you know?
Uh, I figured because it had like the frequency at 1670, it would kind of,
Exactly.
yeah.
And that's enough. There's nothing here that's useful. So you read these, you go back and look at the charts and figure out which one matters. And you did that in under a minute, which is fantastic. All right. So actually we'll come back to that. All right. So this one may appear to be difficult, but if you use the strategy, you may find that it is not as difficult as it appears.
Um, is it B?
It is B. How did you know?
Um, there's like at 0, um, like I just figured kind of because the point where like the lines what do you call it?
Try to
Like
get too focused on a single word. Just keep going. Get it out there.
where they like start or whatever, like it
Uh-huh.
uh is I thought it would be like 10% and 20% just because of where they started. But
But so why is it 10%? It is 10%, but why? Why is 10% in this chart here?
uh because there's only 10.
That's right. 1 out of 10 is 10%, and 2 out of 10 is what percent?
20%.
20%. Yeah, that's it. There's a lot of other words here that don't help. Okay, so before we do the next couple of questions here, what is the smallest number that you can take the square root of?
What's the smallest number you can take the square root of?
Yep. Yep.
uh I don't know, like 2,
Nope.
1.
What's even smaller than 1 that you can take the square root of?
uh 0. I don't know.
Yes. Yes. Very good. That's what I wanted to hear. So why am I putting these numbers up on the screen? Like, why am I not putting up like the square root of like 3, for example? What's different between square root of 0, square root of 1, square root of 4, square root of 9, and square root of 3?
Um, it would be a decimal. I don't know.
Yes.
Okay.
Yeah. So I like this terminology. These on the left here are friendly, and this is not friendly. Maybe you disagree with the language, but the point is that these are nice whole numbers. These are not. Okay. And are there more friendly or unfriendly numbers when it comes to square roots?
Uh, well, up on the screen it was more friendly.
Okay. All right. Now that I put the same number up, try to give me a little bit less a logical answer here. Like there's the same number up. So what I'm referring to is more generally like, do you think there are more nice numbers as outcomes or not nice numbers?
Uh, are you even able to well, probably not friendly.
Yeah, you see that with a little hesitation, but like just between like 1 and 4, there's the square root of 2 and the square root of 3, and between 4 and 9 is square root of 5, square root of 6, square root of 8. There's like 4 numbers that are not friendly. And so there's more unfriendly numbers than there are friendly numbers the way we're describing it here. Okay. So let's say I give you a problem like this. I say that the square root of x plus 3 equals 5. And the options are 0, 1, 4, and 9. Which is the correct answer?
Um, 4.
Letter C. Now I'm going to give you the same question, but this time we're going to change up the answers here. Okay, the answer is still 4, but what is the problem with 2, 6, and 8 based on our previous discussion?
Well, wouldn't they all work too? Well, except 2.
Well, why does 6 work?
Uh, so it's square root is 2.
Yeah, we just made this tables. The only ones that you can take the
Oh, it's
square root of.
unfriendly. It's unfriendly.
Yeah, and that's the whole point is like there are unreasonable answers. Like these on the left, these are the things you can take the square root of. That's great, right? And there's a lot more of them. There's more that you cannot take the square root of than you can. And most of the time they put in answers that you can't even take the square root of. Okay,
Okay.
so let me give you another one here. Square root of 6, sorry, square root of x minus 5 equals 1. Okay. And so they'll put in answers like this: 6, 36, 7, and 49.
Uh, heck, uh, 36.
So you seem uncertain though, right? Little
Well,
bit of
is the square root
hesitation.
of 6?
Right. So you gotta be careful. Like, is the square root of 6 possible? Is it
No.
friendly? No, not in the way we're thinking of it. How about the square root of 7? No, but the square root of 36 is 6, and the square root of 49 is 7, and these are possible. Is that okay? Clear?
Yeah.
Okay. Now, where this gets more complicated is, let's say I ask you to find the square root of x plus 1. And let's say the answers are 1, 2, 3, and 4. Which of these work? Which of these give you a friendly square root?
That's 2. Or
The 2 is the square root
no,
of
no,
3.
no, 3, 3.
That's the square root of 4. That's the only one that works, right? Because this is
Yeah.
the square root of 5, this is the square root of 2. Not friendly, not friendly, not friendly. Any questions on that?
No.
Okay. So when you look at this problem, and I'm going to try to find a few more like this, but when you look at this problem, you want to decide, like, what can you actually take the square root of? Because there might be some here that you can take the square root of, but not all.
Okay. Uh, say 6.
Okay. So square root of 16, that's good. That's 4. Is that the same as 6 minus 2?
Yeah.
Good. Good. Doing great. And you're solving these quickly, which I like as well. I mean, that's also part of this. Like, the strategy only works if you can reduce the time that it takes to solve it. All right, so I got some more questions here for us to try that are like this, and just put them up in front of you here, and let me know what you come up with.
Uh, is it 21?
Yeah, it's definitely not A and not C. Like, these are the only two possible ones. Hopefully that's the way you were looking at it, and
Yeah.
then this ends up being correct. Good. So try to eliminate answers. That way, when you're guessing, you're not guessing, just randomly. You're like, all right, I think this is kind of it. All right, another one here for you to try.
2.
Okay, I agree. All right. Let's do one more here, a couple more here. All right. Tell me what you
Uh, 9.
is 9. Good. Okay, so we're gonna close out here with a couple of more problems here. So this is just we're just doing some random stuff now, but they're all kind of in the world of like looking at the answers, deciding which one is right or wrong and why. What's different or what's the same about them. Go ahead and take a look at this one, see what you come up with. All
Is
right,
it
so this good.
uh is it 1?
So there's actually 3 answers, kind of
Right.
like the other one. It's this point in red, this point in red, and this point in red. So yes, it is C. Good. All right, take a look at another one here. A couple more before we close out today.
Um, is it C?
Okay. How did you come up with that?
Uh, I kind of looked at the numbers 15, 24, and what do you call it?
That
Like
that's
divide
not
them.
here. If C had a 3 in
No, I
front,
know, but
that
like I'm dividing it.
okay. So equivalent means that has to be exactly the same. It's like these, if here's a pizza and here's a pizza, these are not equivalent.
Oh, well, then it would be D.
Yes. Maybe that's was the missing, piece. It's like, oh, take a slice of pizza. Well, I mean, this is the kids pie and this is the adult pie. So, all right. So just to kind of close out the strategy today, just a few final little notes, thoughts for you. Most questions on the actual test are written in this form, which of the following, even in the other sections, okay? So you read the answers next and compare them to one another. You're looking for similarities and differences. Then you go back and you read the rest of it, and you're looking for keywords to eliminate answers. When in doubt, only when you're just totally stuck, but all the ones you were able to answer today, you would guess letter D, not C for this type of problem. All right, great job today, Tristan. Good effort there, especially to close